Okay guys, so in this video we're going to talk about WebSockets in TypeScript. So let's get into it. So basically what we're going to cover is what is a WebSocket and how do we structure our application to use them. So the short answer is that a WebSocket or the WebSocket protocol is just a way for us to communicate between a client and a server in at least near real time. And basically what that means is that you may or may not know that the HTTP protocol is a stateless request-based system where the client makes a request to the server responds, and then that's the end of the interaction. But what if you want to keep a live connection between the two? Let's say that you want to send information back and forth between the server in real time. Well, then WebSockets is just the thing that you are looking for. And these things, they make extreme sense when you have some type of real-time information that needs to happen. Let's say that you are making a IoT application with a bunch of analytic data or something like that that's coming in from different servers, or maybe you're making some type of application such as the one that I've made here, an uploading thing where you upload really big files, so you run some type of job and you want to see in real time the uploading process. Another example would be a live chat or something like that, when you're chatting with people and stuff like that. Then you don't want to have to refresh the page or something like that. You want to have a persistent connection. So the question that I got that kind of motivated this video was, okay, how do we structure this application in such a way that it scales to a fairly big size? And that's what I'm going to show. So first and foremost, let's just walk through the basics. So here is my Webpack configuration. Here is my TypeScript file because we're using TypeScript, and here is my server. This is just an Express server where here I just strap up everything where like I import my app, and I use Socket.io pretty much for anything I do with sockets. There are probably other ways of doing this, but I prefer Socket.io. It's tried and true. And I have some services and stuff like that that we are going to talk about in just a moment. And here is my application. It's a super simple little application where we just go to the root and then we serve up a static HTML file, which is this thing here, where we basically just have an upload of some sort. And we're just gonna, we're gonna use our imagination here. We're going to pretend, but hopefully you can follow along either, anyway. Just use your imagination. It's all gonna be fine. And then here is my HTML file, which just has these few elements here. And then I have this bundle file here because I use Webpack to bundle all of this code. Let's close that for a moment. And here is my entry point file with a little bit of stuff. I see I can remove that, but it doesn't matter. And this is pretty much the entire thing. So what I'm going to do now is I'm just going to showcase what this does. So I click on this choose file thing here, and then I just pick an arbitrary file. And now you're going to see that it changes from loading to processing data, and then it's going to say compiling results, and then running analytics, and then finally it says done in 12 seconds. I don't know if that was 12 seconds, but it felt like it. Anywho, this is pretty much the application. So I'm just simulating now that I uploaded a really big file, and I don't want like the user to be stuck here with some endless lockdown thing. I just want to basically asynchronously do the upload. So under the hood I would do something like, I don't know, I would pull in the binary data from the file or convert it in some fashion, and then I would just send things under the hood until this is actually processed and finished. There are many ways we can do this, but let's focus on the state transition because that's the thing that is interesting, that we actually change that text here. So let's look at how that actually works. So here on the client side, I pull in Socket.io, and then I have a global interface that I declare. So the reason why I declare this global interface is because the window object in TypeScript, because we're working in TypeScript now, doesn't have the concept of custom variables such as this socket. Now, why am I doing this? Well, the simple answer is that I want a global accessible reference to my socket, because when I instantiate my client side, the client side of the socket communication that I'm going to have, I need some way to get at that code, and there are many ways I could pass around this socket reference that I'm creating here. I could do that, but in my experience, it's just simpler to have a global reference to this thing. The reason why this is safe is because I will never overwrite this. As long as I treat this as an immutable thing that I just use to do this, which is the emit, because the socket communication, this socket is just a reference to the socket that I want to use in order to send messages. And since that's never going to change, I just basically use it to call a function. It doesn't really matter that it's a global reference because the value is never going to change. So that's why I keep it on as a global thing, because then I can actually reference it from wherever in my application, assuming of course that this part here runs before anything else. And then I grab my upload field and I grab the text that is under the upload field, which is where we actually show the text, right? And then I add an event listener that just checks if, hey, there was a change event, and I do some validation and typecasting here. And then I check, are there any files in my files list here? If there are any files, then I'm just going to set that text to loading as we saw, and then I'm going to construct an event, and then I'm going to use my socket, and then I'm going to emit the event with a state. And state is just a label that represents the event that is taking place, and then I actually send the event itself. Otherwise, I'm going to just clear that content. And then down here, I have a function that initializes all of my event handlers. So let's look at that. So when we're working with sockets, the way we want to think about this is, we have a term for this, which is called event-driven development. Now, event-driven development basically just means that an event has taken place within the system. Now, you dispatch that event, or the fact that this happened, to some type of event listener. And this is the same way any server works, where you have an incoming network call to your server, and then you have a handler of some sort. This thing here is just using WebSockets, but it's literally the same thing as this thing here. It's just different protocols. So making a network request with HTTP like this is an event that takes place within our process that's running here on the server. And then we add some logic that responds to that event. And we're doing the exact same thing in here. It's the same thing. So what we do here is we have a function that just initializes all of these event handlers, and we add in the upload text element here because, I prefer to not do a global access. I just dependency inject this because that makes it much safer than, because technically I don't know where this function is being called. I just want to make sure that I'm not doing some random access that might actually fail. And then here I use my global socket and I just declare a listener. And then I listen for the different states, and if the state is uploaded, then I set the text to uploaded, processing, compiling, running analytics, and done. And in the done case, we actually get back an event, which is a type of iMessage of type string. We're going to look at that in just a moment. And then I set the text to done in event.data. So this is basically just a handler. You can think of it as the equivalent of a controller or similar for just regular web applications, but it's just for a WebSocket instead. So the pattern should feel very similar. You get some route or some event that comes in, and then you have a handler function that just takes in the data that came with that event. And for those of you who may be using React or Redux or whichever you're doing, like you can use Redux without React, of course. This is where you would take in such a thing such as an event here and use something like Redux, something like store.dispatch to actually dispatch the fact that this was happening into your React application or your state and do mutations. So this is the core of event-driven development, and this scales extremely well. This is by following this pattern, you have the exact same structure on the client side as you have on a server. So I highly recommend following this pattern. All right, let's flip this and let's have a look at the application itself. So here is our server. We have instantiated our socket here, and we got this IO thing here, whatever that is. And then we have a connection. So this is now a connection where the client has connected to our server. So this is now a connection between the specific client and this server. So if we have a look at the input, the init upload event handlers, you can see that there's is pretty much the same thing as we saw earlier. So basically all we're doing here is that we're declaring that, okay, on this socket, create a route handler that's going to fire when there is a loading event that takes place. All right, so there's a loading event, and then I've only faked these things here, but just hopefully you can follow along anyway. So the loading state will send us some type of information, right? And here is my little fake service here. And this is something that, I'm faking this, but just try to take away the message from this. So the idea here is that you create a layer between the actual business logic and the socket event handler. Think of this event handler, this thing here, as just this is the glue. This is the glue that connects the incoming request to the output. That's all it does. It doesn't know anything about, how to gather data or process data or do whatever business logic that you want to do, right? You have a service layer or some layer that knows how to do that. So this, and that keeps this very compact, because all this part of the code wants to know about is how to communicate between the client and the server. That's all it knows. And if we look here, all it's actually doing is that, okay, so it's calling a function that is going to gather some data, which returns a promise of some sort. As you can see here, I'm kind of using a little sheet here where I'm just faking the fact that there's a promise that takes 3 seconds for each of these things, right? And then it dispatches the uploaded event, and then that it's going to start processing, and then it starts processing for a certain amount of time, and then it sends back and says to the client, okay, now I'm compiling. It compiles, and then it says, hey, I'm running some analytics now, and then I analyze that data, and then I create an event, and then I emit the done. Well, we're going to look at that in just a moment, but then I just emit back the fact that I'm done with the event and the data that is associated with it. And the term we use for this sort of thing is, well, not necessarily pub sub, but it's message dispatching basically. It's just you're sending messages between two entities, a client and a server in this case, and so some shape or like mapping your models to that sort of mindset I think is very useful. So I have this little socket library here where I have some states, and then I have an interface for a message of a type of something, and all it has is a socket state, and a socket state is just an enumeration that holds the different states, or you don't have to call it states. It can be anything. It can be types. It can be whatever you want to call it, but I like to call them states. So there's a state, and there's some type of data that comes with that state. So I can send a string, I can send a number, I can send an object, I can send anything over the wire, as long as it serializes down to JSON in some fashion. And then I have a little higher order function here that helps me create these different states. So I take in a type of t with a socket state, and that gives me back a function that expects the value of t and returns a message of t. And this is just that object. So that way I can just use this shorthand way of working, so I can declare quickly a bunch of functions that know, all right, I'm going to call these things here, and they already know that they're going to return they expect a string or a void or whatever input I want, right? And yeah, that creates these tiny little objects that represents a message that's going to go back and forth between the client. And this thing here is pretty much the whole structure. So by doing this, you keep a very nice and clean interface between the client and the server. And as long as you embrace this idea that you think in an event-based fashion, and that the top level where the socket is actually starting to listen, that level is just a controller level, like as in any MVC pattern. It's just designed to to be the glue between the client and the server. It's only allowed to know about sending and receiving messages. All the actual logic needs to go one level down into a service or some function that knows how to do this. If you just abide by that, it's going to be very simple for you to create fairly sophisticated systems using WebSockets. So I think that's pretty much it, really. So hopefully you found this useful. Have a great day.